Hey, my name's Brent, and I'm going to show you some activities you can do for the math standard MCC 7G2. This is the standard right here. Draw freehand with ruler and protractor and with technology geometric shapes with given conditions. Focus on constructing triangles from 3 measures of angles or sides, noticing when the conditions determine unique triangle, more than one triangle, or no triangle at all. So our main focus today is going to be with triangles. Now, the activities I have for you are what I consider reinforcement activities. Students are going to need to know about triangles before they do these activities. These are good activities to reinforce what they know. Now, to me, there's 6 different triangles that your students are going to need to know about, because the standard talks about sides and angles. Well, if you're classifying a triangle by its sides, it's either going to be scalene, isosceles, or equilateral. Now, scalene is a triangle with side lengths that are not equal to each other. None of them are equal to each other. Isosceles is a triangle that has 2 side lengths that are equivalent. And then an equilateral triangle is a triangle that has all the same side lengths. Now, that's your different types of triangles with side lengths. You also have triangles classified according to their angles. Now, a right triangle, simple enough. Makes a 90-degree angle. If you have an obtuse triangle, you have at least one obtuse angle in the triangle. Now, the acute triangle is a little bit different, and people sometimes confuse it, because with an acute triangle, all 3 angles in the triangle have to be acute, meaning it has to be less than 90 degrees, whereas obtuse on the obtuse triangle is more than 90 degrees. So that's your different classifications for your angles. Now, with this, we're going to use a ruler and a protractor, because rulers will be used for your side lengths, protractor will be used for your angle measures. Now, with my activity, we're going to use whiteboards. Now, these whiteboards, you actually don't buy them like this. I got this from a very large board at like Home Depot. They sell them probably 6 foot by 8 foot. They're very large boards. And what you can do is get the people at Home Depot to cut them out for you. These are 1 foot by 1 foot boards. But it come originally as a big, huge whiteboard that you would see. And so I had these cut up, and they're a good investment because these last for years and years and years and years. The only thing you got to worry about supplying is maybe markers and erasers. And so, but with mine, this is what they look like normally. Got the wood on the back, just the whiteboard. And I've kind of made some modifications to mine. I taped mine. They look a lot better than these, and it keeps your sides from wearing down so good, and they're slick. They don't get caught on anything. But these are definitely a good investment. Another thing I think you need to think about doing is you got to have erasers, because you don't want kids, taking their hands, wiping it off, because that just leads to mess. But this right here is actually what is called a Mr. Clean Magic Eraser. They're usually about that long. This one's been cut in half. And these things are good because they wipe off this dry erase stuff without any Windex or anything. Even if you've let it dry on here for a while, this stuff right here, it will take it off. These are excellent to use for those. And then obviously just your normal dry erase markers. Now that's the materials you're going to need for my activity. It's the 5 things I have here. Now, like I said, these are reinforcement activities. And what I would do is, the reason you have them cut out like this is so that each student can have one in your classroom. Now, if you can't afford, enough of these for each student, try to at least get it so you can pair them up. So, let's do one of our triangles. You can give your students, let them start with triangles that are classified by their side lengths. Tell your students to make you an isosceles triangle. So what you can do, tell them, say, make me an isosceles triangle with the measurement being 5 inches. So, as we know, their prior knowledge, they should know that an isosceles triangle has 2 sides that are congruent. So they'll take the ruler down to 5 inches. Okay, there's one side. Take the ruler again, line it up here. Let it come down to 5 inches. Okay, and then they just need to close their triangle. Okay, now we have a triangle. This is 5 inches. This is 5 inches. And then it really doesn't matter what this is. It's about 4.9 4.9 inches. But it really doesn't matter what the bottom one is, because in an isosceles, all we're worried about is the fact that we need to have two of them that are equivalent. So that would be an example of an isosceles triangle. You can do the same thing with like a scalene triangle or a equilateral triangle. It's just all according to what the side lengths are. Let's just, for example, do a scalene. I mean, scalene, you could do one being 5 inches, and then you could do another one that's like way off, like 8 inches. Connect them together right there. And then this one right here would end up being a little less than 8. That one's about 7.9. So you got, see, each of these would be something different. So that would be an example of a scalene triangle where none of the sides are equal to one another. So that's how you would let your students use a ruler to show the different side lengths. And I think this is important because this is more than a worksheet that the students are doing. When they actually construct them and do this hands-on, they're going to remember, oh, an isosceles triangle, I remember that. That was a 5-inch one and then a 5-inch one, and then the bottom didn't matter. And then they'll remember, like, scalene triangle, you know, oh, those are the ones we got to do all the crazy side lengths. It didn't matter because we didn't want none of them to be the same. And I think that's very important for students. If they do hands-on, that's what they remember. And so I think this is very good, and using the ruler kind of reinforces that, you know, thought process of, you know, that's how we do triangles that are classified by their sides. Now, you'll still use the ruler for this, but our big thing for the angle measures is our cheapo 50 cent protractor. So what you're going to do for this one, though, is say I tell my students, draw me a right angle. Right triangle. Now, what does a right triangle have? It has one right angle. So what we're going to do is we're going to line up here, and if you can see here, there's a little line right here on your protractor. Tell them to, you know, maybe put them a little dot right there, and then draw them a straight line, like that, okay? And what is a right angle? Well, it's 90 degrees. So you want to put a little dot right here above 90 degrees, okay? Now, we're done with our protractor. Let's get that out of the way for now. Now, tell them to go back to their ruler, line up that dot with that line that they drew, and let them draw it down, okay? That is a 90-degree angle. Tell them just to finish off the triangle. Connect your sides here, and there you go. You have a 90-degree angle in there, which makes a 90-degree triangle. And they can do the same thing with an obtuse triangle or an acute triangle. I mean, let's just do an obtuse one. Once again, same method. Line up with your little line, put your little dot, draw you a straight line. Now, what did we say an obtuse triangle was? Well, it's got one angle that is an obtuse angle. And what's an obtuse angle? It means it's greater than 90. So here's 90, here's 100, 110, 120. Oh, let's do something kind of crazy. Let's go 150 right here. So we'll put us a little dot right here at 150. Pull our protractor out of the way. Line up our dot with our other line that we've already drew. Connect it, and then finish off a triangle. What does a triangle always have? It has 3 sides. So this is going to be a really odd looking triangle. And there you go. That's an obtuse triangle. And why? Because this angle right here measures 150 degrees, which is an obtuse angle. And what is the definition of an obtuse triangle? It has at least one angle that is obtuse. So that would be an example of an obtuse triangle. And once again, this is good because it's hands-on. Kids remember hands-on stuff. This is more than, you know, doing problems on a worksheet. You know, this is very constructive. This is hands-on, lets them really understand what they're doing, and especially with the protractor. Because now, if your class hasn't touched the protractor yet, you're going to need to teach them how to use it. If they have used it prior in the year, this is great review for that. But this will help them really well remembering the angles, the different classifications of the different triangles. Now, that's a lot of hands-on right there. I've also got some activities here that I will include in a Word document that will be attached below or in the description below this video. I have 2 games here for the different classifications of triangles. Alright, the first one here is on Saxon Math, and here's the website, Hell Media. But like I said, I'll put this in the description below. But this one is good. This has it just does the different angle classifications. Like take this one right here. That's a right angle. Move it down into the right. That's also a right angle. Move it down to the right. That one right there. That's an obtuse. Drop it down in there. And the good thing about this is as kids do it, say, okay, that's an acute angle. We see that. Let's drop it down into the obtuse and watch what happens. It goes back. It won't let me put it there. And so this game is really good reinforcement for kids that have trouble looking at angles and trying to tell if they're right, obtuse, acute, and this really helps reinforce it because as you can see, there's probably 20 or 30 examples here, so there's all type of different examples for them to look at. That's one. Now that is like angle identification. I think that's good just to help kids that have trouble with angles. Now here's the real good game I like. And the reason I like it is because there's no pictures. Now it gives you some prior information, but this is what they have learned. We've done talked about what a right angle, an obtuse triangle, and a right triangle are. We've done talked about all that. But down here is the game, and it's really, really good. Now, what you see here is you've got like angle A of the triangle is 21 degrees, angle B is 117 degrees, angle C is 42 degrees. Now, from this, what is this triangle? Well, we know that it's obtuse, so we click obtuse. It tells us correct. Then you got this one. A is 90 degrees, B is 13 degrees, and C is 77 degrees. Well, right away, we should know what kind of triangle this is going to be because it's got one right angle. And so you could do that. And with the kids, I think this is good because it makes them, they don't just get to look at a picture. And because there's many times we talk about in math, this is not drawn to scale. You hear that a lot in math when you're looking at different geometric figures, and they'll tell you this is not drawn to scale. Students need to have a working knowledge of what the different numbers mean, what the degrees mean. And I think this is real good. And it's also got a timer at the bottom, so you can race against each other. The timer on here is up to 79 minutes. I was playing with this game a little while ago, and I think it's just really good, and it even keeps you how many you got correct, how many you got incorrect. You could put kids on teams, let them race one another, or anything of that manner. And these are good to play, especially in the modern day classroom, because we got smart boards now. And smart boards are wonderful to use games like this, because kids can really compete against one another. You can have groups. And so these are good games to integrate with the technology part of the standard because of the smart board. But this is just some of the activities I had for the different classifications of triangles, and I really feel like it hits that standard that I introduced at the beginning of this video. And like I said, these are just reinforcement activities, but I think they're really well to help kids really have a working understanding of the material. But anyway, thank you for watching my video, and these are your activities for MCC 7G2. Thanks for watching.